In our second chapter of geometry, we have learned Pythagorean triplets, also similarity of right angle triangles, also theorem of geometric mean, and also we have proved Pythagoras theorem. Now, using these concepts, we will solve examples from practice set 2.1. Practice set 2.1, example 2, question number 2. In the figure, angle M and P, angle M and P is equal to 90 degree. That means this is right angle. And segment NQ, perpendicular segment M. Segment NQ perpendicular segment M. MQ is equal to 9. QP is equal to 4. Then find NQ. So we have to find NQ here. So here given MQ is equal to 9 and PQ is equal to 4. So we have to find NQ. So here, according to the given information and according to the figure, NQ is a perpendicular drawn on the hypotenuse. So we will use here the theorem of geometric mean. Therefore here, according to the theorem of geometric mean, NQ square is equal to MQ multiplied by QP. Theorem of geometric mean. Now for the value of MQ and QP. So here we get 9 multiplied by 4. So MQ is equal to 9, QP is equal to 4. And therefore NQ square is equal to 9 4s are 36. Now take square root of both the sides, we get NQ is equal to root 36, that is equal to 6. So our answer is NQ is equal to 6. This is our answer. Now we will solve the next example. Question number 3. In figure, angle QPR is equal to 90 degree. See this angle QPR. This angle is of 90 degree. And segment PM, perpendicular segment QR. And QMR is our collinear points. PM is equal to 10 and QM is equal to 8. We have to find QR. Now see here, this is the original right angle triangle, QPR, and QR is the hypotenuse. And here PM is the perpendicular drawn on the hypotenuse. And due to this perpendicular, we get two more right angle triangles. Triangle PMQ and triangle PMR. Now, taking triangle PMQ, we will find PQ. So PQ is the hypotenuse of triangle PMQ. Now first consider triangle PMQ. In the right angle triangle, triangle PMQ. So PQ is a hypotenuse, and therefore PQ square is equal to PM square plus QM square. Pythagoras Theorem. Okay, now put the values here. PM is equal to 10, that means PM square means 10 square, plus QM is even 8, that means QM square means 8 square. That is equal to 100 plus 64. Therefore, PQ square is equal to 164. Now taking square root of both the sides, we get PQ is equal to square root of 164. After simplifying this, we get here two factors are 4 and 41. Here 4 ones are 4 and 4 fours are 16. These are the two factors. Now 4 is a perfect square. Take square root of 4. Therefore PQ is equal to 4. Square root of 4 is 2. And under root 41 as it is. So here PQ is equal to 2 root 41. So this length, we got this length 2 root 41. Okay. Now we will find QR. Now here we will use the property of similarity of right angle triangle. For that, we know that if you draw a perpendicular on the hypotenuse, then we get two right angle triangles. These original right angle triangles and these newly formed right angle triangles all are similar. Already you have studied this property. So using that property, now we will solve the next part of this example. Now here consider triangle PMQ. And triangle PRQ. These two triangles are similar because similarity of right angle triangle. The reason is similarity of right angle triangles. So that means if these two triangles are similar, then their corresponding sides are in proportion. And therefore, we will take the ratio of corresponding sides. Pm upon Pr is equal to PQ upon PR is equal to MQ upon RQ. Okay, now here we will take these two ratios, PQ upon QR. Now see here the one correspondence of vertices of these two triangles. Triangle PMQ and triangle PRQ. This is the corrected one-to-one correspondence of vertices. Okay, now using this correspondence, we will take the ratio of corresponding sides. That means here Pm upon Pr is equal to PQ upon QR is equal to MQ upon PQ. Okay, now here we have Pm is equal to 10. Okay, and Qm is equal to 8. And also we know that PQ is equal to, we have calculated it as 2 under root 41. So for that we have these two values and this value is given here. We have to calculate this value QR. So we will take these two ratios. Therefore PQ upon QR is equal to MQ upon PQ. Already we have calculated these two values. That means PQ, value of PQ is equal to 2 under root 41. So put this value here. So we have to find this value. QM, that means MQ is given 8 and PQ is equal to 2 under root 41. Now by cross multiplication, 8 into QR is equal to 2 under root 41 multiplied by 2 under root 41. And therefore QR is equal to, so here we get 2 into 2, 4. Okay, under root 41 into under root 41 we get 41. So multiplication of this is, product of this is 4 into 41 upon 8. This is 8. Now divide again this 8 by 4. We get 4 to the 8. So here we get 41 upon 2. And therefore QR is equal to 41 upon 2 we get 20.5. So this is our answer. So therefore the length of QR is equal to 20.5. Okay, now see here question number 7. In figure, angle DFE is equal to 90 degree. Angle DFE 90 degree. That means triangle DF is right angle triangle and ED is the hypotenuse and AFG perpendicular ED. That means a perpendicular drawn on a hypotenuse. And if GD is equal to 8, FG is equal to 12. So find EG. So first find EG, the second find FD, and third find EF. Now see here, due to the perpendicular drawn on a hypotenuse, here we got two more right angle triangles. First, this is original right angle triangle DFE. After drawing perpendicular on hypotenuse, we got two more right angle triangles. That means triangle EGF and triangle FGD. Now already we have studied that property, similarities of right angle triangle. That means these three triangles are similar. Now first we will find EG. For that we will use the theorem of geometric mean. Here mg is the altitude on drawn hypotenuse. So by the theorem of geometric mean, here we get fg square is equal to gd multiplied by eg. Theorem of geometric mean. Now put the given values here. Mg is given 12, therefore 12 sphere. Gd is given 8 multiplied by Eg. We have to find it. So here this is the answer of our first question. Okay. Now 12 square we get here 144 is equal to 8 into Eg. And therefore Eg is equal to 144 upon 8. Is equal to 8 ones are 8. And we'll get this in fraction. Okay. So here 8 ones are 8, we get 6, 8 8s are 16 like this. Okay. So or you can find MD using Pythagoras Theorem. If we find this EG, so the EG will be according to this 1 upon 44 upon 8. So after dividing 144 by 8, here we get 8 ones are 8 and 8 8s are 64. That means 18 8s are 144. So here we get here EG is equal to 18. This is our first answer. EG is equal to 18. Now we have to find FD. For that we will use the similarities of right angle triangle. Now see here, consider these two triangles. Triangle GFD and triangle FED. For our second answer, triangle GFD and triangle FED. Okay. Now see here. GFD. This is also right angle triangle. And FED. This is also right angle triangle. These two triangles are formed due to this perpendicular. And we have studied that property. That means similarities of a right angle triangle. And due to that property, these two triangles are similar. Similarity of right angle triangle. So triangles are similar, therefore their corresponding sides are in proportion. Therefore GF upon EF. GF upon EF is equal to FD upon ED is equal to GD upon FD. Okay. Now see here. We have to find FD. We have to find this length. And here we have length of ED is equal to 18 plus 8. And length of GD is equal to 8. So using these two ratios, we can find FD. Okay. Therefore, FD upon ED is equal to GD upon FD. Corresponding sides of similar triangles. Now, if we put the values here, here we get FD into F2 or FD upon ED. So length of ED is equal to 18 plus 8, we get here 26. And GD is equal to 8 upon FD. We have to find this length. Now by cross multiplication, FD multiplied by FD. We get FD square is equal to 26 multiplied by 8. So we will simplify this. So by taking square root we get FD is equal to square root of 8. Okay. Now this 26 we can write 13 into 2. Okay. 13 into 2 into 8 here. 13 2s are 26 into 8. Now again we can write here 13 into 8 2s are 16. So here we get 13 multiplied by 16. These are the two factors. And here 16 is a perfect square. So take the square root of 16. So here we get FD is equal to square root of 16 is 4 and under root 13. So this is our second answer. FD is equal to 4 root 13. Now we will solve, find E of. Now considering the same two triangles here, GFD similar FED. Okay. So corresponding sides GF upon EF is equal to MD upon ED is equal to GD upon MD. Similarity of right angle triangle. Okay, same reason. Now here we have to find EF. Okay. For that we have to take this ratio and another, which ratio here we have to take? We can take this ratio and choose any one ratio from these two. See here, we have FD is equal to, we have calculated FD is equal to 4 root 13. We have GF is equal to 12. We have ED is equal to 26. So we can use these two ratios. Now put the values here. So here GF is equal to 12. EF we have to find this. FD already we have that FD is equal to 4 under root 13 and ED is equal to 26. So by cross multiplication we get here now by cross multiplication here we get EF multiplied by 4 root 13 is equal to 12 multiplied by 26. And therefore EF is equal to 12 multiplied by 26 upon 4 under root 30. And I have divide this 12 by 4 to get 4 3s are 12. Okay. Multiplied by 26 upon root 30. Okay. Now here, to simplify this, again we will write the factors of 26, 3 as it is, 2 into 13. Okay. 13 to the 26. Again we can write the factors of 13 as root 13 into root 13. Okay. That means 3 into 26 we can write like this. 3 into 2 into root 13 into root 13 upon root 13. Now root 13 gets cancelled. So our answer is EF is equal to 2 3s are 6 under root 13. 6 under root 13. Therefore EF is equal to 6 under root 13. Or you may use these two ratios. GF upon EF is equal to GD upon FD. If you use these two ratios, then also you will get this value. Okay. If you use these ratios, it will be easier than this. Because here there is more calculation here. Here you will get less calculation and you can find easy. Okay. Now we will solve the next example. Now question number 9. In the figure, M is the midpoint of QR. M is midpoint of QR. Angle PRQ is 90 degree. And we have to prove that PQ square is equal to 4 PM square minus 3 PR square. Now here given that M is the midpoint. Of QR. That means RM is equal to MQ. That means this RQ is double of RM. That means here 2RM is equal to QR. M is the midpoint, that means here QR is the double of RM. And therefore, RM is equal to QR upon 2. Statement 1. Okay. Now, we will consider triangle PRM, right angle triangle PMR. So here PM is hypotenuse. So by Pythagoras theorem, here we get PM square is equal to PR square plus RM square by Pythagoras theorem. But RM is equal to QR upon 2. To put the value of this RM. Therefore, PM square is equal to PR square plus QR upon 2 bracket square from statement 1. And therefore, PM square is equal to PR square plus squaring this bracket we get QR square upon 4. Now simplify this. To simplify this, multiply both the sides by 4. After multiplying both the sides by 4 we get 4 in PM square is equal to 4 PR square plus, if you multiply this term by 4, 4 gets cancelled, here remains only QR square. And therefore, from this equation we get QR square is equal to 4 PM square minus 4 PR square. So this is our statement 2. Okay. Now, right angle triangle PRQ. PQ is a hypotenuse. So, again using Pythagoras Theorem, we get PQ square is equal to PR square plus RM square. Therefore, here QR square, PQ square is equal to PR square plus QR square. Pythagoras Theorem. Now put the values of QR here. So QR square is 4 PM square minus 4 PR square. Therefore, PQ square is equal to PR square as it is plus, put the value of QR square here, 4 PM square minus 4 PR square. So from equation 2. Therefore, PQ square is equal to 4 PM square as it is and minus 4 PR square plus PR square. That means 1 minus 4 will be minus 3 PR square. And therefore, this is our proof. PQ square is equal to 4 PM square minus 3 PR square. This is the proof. So now, to solve the remaining examples, I will explain how to solve example number 10. Now see here. Example number 10. Walls of two buildings on either side of a street are parallel to each other. A ladder 5.8 meter long is placed on the street such that its top just reaches the window of the building at the height of 4 meters. On turning the ladder over to the other side of the street, its top touches the window of the other building at height 4.2 meters. So find the width of street. Now see, according to the given information, first we have to construct a rough diagram. Suppose this is AB is a street. Okay. Now at point A, one building is here. Suppose AC is one building and its height is 4 meters. Okay. Now other building. Suppose here at point C is the window here of first building and this height is at height 4 meters from the base. Okay. Now the window of the other building is at height 4.2 meters. Suppose this is point D. B. Okay. Now the ladder is placed on the street such that its top just reaches the window of building at the height of 4 meters. Suppose at this point here E, a ladder is kept and its this side. And if we turn this ladder, it touches at point D. So this height is same. The height of ladder is 5.8. Okay. So here we have two right angle triangles because buildings are perpendicular to the street. AB is the street, AC is the one building. Okay. At point C is window at height 4 meters. Here at point D is the window of other building at height 4.2 meters and height of ladder is 5.8. First time ladder is kept in position EC. So using Pythagoras Theorem, you can find AE. In triangle AEC, use Pythagoras Theorem, find AE. Now, in another triangle, the height, that means the ladder in this position, ED. The height is same, 5.8. In this right angle triangle, BD is 4.2, AD is 5.8, find EB using Pythagoras Theorem. Then adding AE and EB, you will get the width of the street. AE plus EB. In this way, you can solve. You have to use only Pythagoras Theorem here. Okay, now to try to solve the remaining examples.